Welcome to Study Loop.
This is the answer to Chapter 22, problem number 13 from the Smith Organic Chemistry textbook. This problem asks us to draw a stepwise mechanism for this reaction that we're given here, and it's the reaction between an alcohol and an acid chloride. And then we're told, that this was used to synthesize a natural product. Okay, so the mechanism is going to be 3 steps. It's going to be nucleophilic attack by the alcohol on the acid chloride, deprotonation of that product, and then elimination of the chloride ion in order to get the final product. Okay, so the first step is going to look like this. One of the lone pairs of the alcohol will act as a nucleophile. And so we'll get this. Okay, so this oxygen is only going to have one lone pair now, and it'll have a positive charge. And this oxygen will have 3 lone pairs and will have a negative charge. And so the next thing that needs to happen is there's some pyridine in this reaction. And so that is going to come along and deprotonate the oxygen that is the remainder of our alcohol nucleophile. So pyridine has a lone pair on this nitrogen. It can grab this hydrogen, and these electrons can revert to the oxygen. And so that is now deprotonated. Okay, and so the very last thing that's going to happen here is that this oxygen with 3 lone pairs and a negative charge is going to close back down, so to speak. So it's going to reform its double bond here, and that is going to kick this chloride ion out. And that's fine because the chloride ion is a good leaving group. And so it is happy to leave with those electrons. And so that gets us to our final product here, which is A. Okay, and so that's the stepwise mechanism of the formation of A from these 2 starting materials. Again, it's 3 steps. It's the nucleophilic attack on the acid chloride, deprotonation of the residue of that alcohol that was the nucleophile, and then the tetrahedral intermediate, the oxygen closing back down to reform that double bond and kicking the chloride ion out. And that's the answer to Chapter 22, problem number 13.